Chapter 24, The Moving Ocean. This is the final chapter in Unit 6, and there are three sections: 24.1, Surface Currents; 24.2, Currents Under the Surface; and then 24.3, Tides. Before we begin this chapter, a couple review topics in regard to physical science. One is usually warm water or air rises above cool water or air. You need to make sure you remember that. And then the second concept is water changes form by freezing, evaporation, and condensation. For 24.1, surface currents. Our two objectives are describe the relationship between winds and surface currents. Number two is describe patterns of different types of surface currents. We have our vocabulary words there. Make sure you pause, get those definitions down before we begin. That way you have a concrete idea and start getting these concepts understood as we go through each slide. Now, the water in the oceans is constantly moving. Obvious motions such as waves and subtle motions that usually involve large water masses are called ocean currents. Now, a surface current is an ocean current that generally flows in the upper 1,000 meters of the ocean. Wind is the driving force of most ocean surface currents. So here's a diagram of global ocean currents. What do the red arrows represent? The warm currents, good, and the blue arrows are the cool currents. Now, in what general direction do cool currents flow? Now, most of them flow away from the poles toward the equator. Now, in general, what direction do warm currents flow? There might be some exceptions, just like the cool currents, but most of the warm currents flow away from the equator towards the poles. Now, in which direction do circular currents in the northern hemisphere turn? The answer is either going to be clockwise or counterclockwise. It's going to be clockwise in the northern hemisphere, and in the southern it's counterclockwise. Now, many surface currents come from either trade winds or westerly winds. The purple arrows on the map show wind patterns, and the blue arrows show current patterns, ocean current patterns. I want you to locate the north equatorial current. So go back, check this out. We have the north equatorial current right here in the South Atlantic. Which winds create that current? Very good. Northeast trades. So the northeast trade winds drive the north equatorial current. Now, which winds create the North Atlantic drift? Here's the North Atlantic drift. We can go back to this map here. There's the North Atlantic drift right up there. It's the westerlies. Good. Now, what is the relationship between the surface currents and the winds that produce them? They move in the same direction. Now, predict the direction of hurricane winds along the east coast of North America. Good. They would travel northeast. Now, warm currents, including the Gulf Stream below, flow away from the equator on the western side of the ocean basins. Now, red is warm areas, green is intermediate, blue is the coolest, and yellow is the largest. This is a picture of the Sargasso Sea. Cold currents flow toward the equator on the eastern side. A countercurrent flows in the opposite direction of a wind-related current. Now, scientists have estimated that the flow of cold water from the Arctic has decreased in the last 50 years. The decrease may be due to the melting of polar ice. The dense Arctic current flows in the ocean depths toward the equator, where it causes warm water to flow back toward the Arctic. The Gulf Stream is part of this warm water flow. Scientists are concerned that a reduced Gulf Stream would decrease the average winter temperature of the United Kingdom by an average of about 11 degrees Celsius. Now, a ring that forms on the Sargasso Sea side of the Gulf Stream has a core of cold water from the continent side called a cold core ring. Now a ring that forms on the continent side of the Gulf Stream has a warm core ring from the Saragossa Sea. So this false color satellite image represents values of heat radiation from the sea and overlying atmosphere. So locate the cold core ring in the image. Look within the yellow area for a circle of blue or green. Now where are warm core rings formed? So you see cold core ring here, could possibly be one developing here, and then you have a warm core ring near the center of the image. So countercurrents flow in the opposite direction of the wind-related currents. They can flow at or beneath the surface. So they flow in the opposite direction of the wind-related currents. They flow at or beneath the surface. A couple examples include the equatorial countercurrents and the Cromwell current. Now the Cromwell current is a major ocean current due to its size and volume. The Atlantic and Indian Oceans also have many countercurrents. It'd be wise to go ahead and go through the 5 section review questions just to make sure you understand these concepts better in 24.1. Next up will be 24.2.